Welcome back. Today, we're journeying into the life cycle of stars, from their formation to their ultimate fate. Stars undergo remarkable changes over billions of years, shaping galaxies and even the elements that make up life itself. Let's dive into 18 fascinating facts about how stars form and evolve over time. Did you know that stars begin forming in giant molecular clouds, which are massive regions of dust and gas? These clouds are often cold and dark, providing the perfect conditions for star formation to start. Did you know that a region in a molecular cloud needs to reach a critical density before gravity can overcome gas pressure, causing the cloud to collapse and form a protostar? This initial collapse can take thousands of years. Did you know that protostars are surrounded by dense disks of gas and dust as they form? These disks can eventually give rise to planets, moons, and other celestial bodies in the young star system. Did you know that stars form through a process called nuclear fusion, where hydrogen atoms in the core are fused into helium under extreme pressure and temperature, releasing vast amounts of energy? Did you know that once nuclear fusion ignites in a protostar, it officially becomes a main sequence star? This is the longest stage in a star's life cycle, where it maintains a stable balance between gravity pulling inward and fusion pushing outward. Did you know that the lifespan of a star depends on its mass? Massive stars burn through their fuel much faster and live shorter lives, millions of years, while smaller stars like red dwarfs can live for tens of billions of years. Did you know that during the main sequence phase, stars convert hydrogen into helium? This process releases energy in the form of light and heat, making the star shine brightly in the night sky. Did you know that once a star exhausts its hydrogen fuel, it enters the next phase of its life cycle? For medium-sized stars like our Sun, this marks the beginning of the red giant phase, where the core contracts and the outer layers expand. Did you know that red giant stars can grow to hundreds of times their original size? During this phase, the outer layers are cooler and appear red, while the core temperature rises, eventually fusing helium into heavier elements like carbon and oxygen. Did you know that stars that are 8 times the mass of the Sun or greater enter a supergiant phase after leaving the main sequence? These stars fuse elements all the way up to iron, releasing huge amounts of energy. Did you know that supergiants can explode in a supernova when they run out of nuclear fuel? This explosion releases heavy elements like gold, uranium, and platinum into space, enriching the galaxy with material for future stars and planets. Did you know that the remnant core left after a supernova can become a neutron star or a black hole, depending on the original star's mass? Neutron stars are incredibly dense, while black holes have gravity so strong that not even light can escape. Did you know that stars like our Sun will end their life in a less dramatic way? When the outer layers of a red giant are ejected, they form a planetary nebula, leaving behind a white dwarf, an Earth-sized, dense remnant of the original star. Did you know that white dwarfs eventually cool and fade over billions of years? Scientists theorize that white dwarfs will become black dwarfs. But since the universe isn't old enough, no black dwarfs have formed yet. Did you know that red dwarf stars, the smallest and most common type, burn their fuel so slowly that they can live for hundreds of billions of years, meaning none of them have yet reached the end of their life? Did you know that star clusters, such as open clusters and globular clusters, often contain stars of the same age? By studying them, astronomers gain insights into how stars of different masses evolve over time. Did you know that stars can change their brightness as they evolve? Cepheid variables, for example, are stars that expand and contract, creating regular pulsations that help astronomers measure cosmic distances. Did you know that star formation is a continuous cycle in galaxies? When stars die in supernovae, they release gas and dust into space, which contributes to new generations of stars, keeping the cycle of stellar birth and death alive. We hope these 18 facts gave you a clearer picture of the fascinating processes stars undergo from birth to their final stages. Stars play a vital role in creating the building blocks of life and reshaping the universe. If you enjoyed these insights into stellar evolution, be sure to like the video and subscribe for more cosmic explorations. Let us know in the comments which fact amazed you the most. Thanks for watching, and we'll see you next time.